Good morning, ladies and gentlemen. Today we are going to be talking about decimals again and how they work in our number system, as well as how to add, subtract, multiply, and divide them. So the first thing we're going to talk about is how they work in our number system. Now, we know very well how it works with up to millions all the way down to ones, and it's actually very similar when we're working with decimals also. So at this stage we're only working with hundredths and tenths, but what I want to show you is how hundredths turn into tenths and how tenths turn into wholes, and it makes sense in our number system the way that we've learned it so far. So if I started off by looking at 0.01. That is 1/100th. I have 1 in my hundredths column. Okay. And if I kept increasing that, it would be 0.02, 0.03, 0.04, all the way down until we got 0.09. 100th plus 100th is 200ths. If I add another hundredth, it takes me to 0.3, 0.4, 0.5, 0.6, 7, 8, 9. Once I have 9 hundredths, if I add 100th to that, I end up with 10 hundredths. 10 hundredths is the same as 1/10. So as soon as this 9 has an extra hundredth added onto it, we end up with 0.1. And you could put a 0 here as a placeholder to show that you now have 10 hundredths, but 10 hundredths is the same as 1/10, and we have that in our tenths place there. If I started off with 0.1, what's bigger than 0.1? You might be tempted to say, well, 0.2 is bigger than 0.1, and you'd be absolutely right. But there are numbers between 0.1 and 0.2 because we have hundredths also. So what's bigger than 0.1 but still smaller than 0.2? Well, because I have hundredths that are in between my tenths, well, 0.11, 11 hundredths, or 1/10, 100th. If I had 0.12, that would also be bigger than 0.1, 0.13. And if we keep adding these up all the way down, we'd eventually end up with 0.19, and we could add one more hundredth, and I'd end up with 0.2. That's 2 hundredths or 2/10ths or 20 hundredths. So this is quite interesting because it shows us that this decimal point only really tells us that we're starting to deal with fractions of a whole, but the way that we deal with these decimals actually stays largely the same as how we dealt with all of the other numbers before it in our number system. So a question that I asked a few people on our online chats was, if I had 1.2 and 1.3, could you give me a number that is between 1.2 and 1.3? And when I say between, it obviously means bigger than 1.2 but smaller than 1.3. And this stumped a lot of us. So what I want you to think of is, well, if I've got 1.2, that's 1 whole and 2/10ths, and I've got 1 whole and 3/10ths, are there numbers between 1.2 and 1.3? Well, yes, there are. So because we've got tenths as our biggest place value at this stage, all we need to do is say, well, what could I add onto that would make this bigger without getting bigger than 1.3. So I can't add tenths because there's only a tenth between these, but I could add hundredths. So there are actually a whole bunch of numbers between 1.2 and 1.3. 1.21 is the first one, 1.22, 1.23, all the way down to 1.29 would be numbers between 1.2 and 1.3. Now, if we went ahead and dealt with thousandths, we'd be able to add a whole extra column. And if we dealt with 10 thousandths, there'd be a whole other extra column. And in fact, there are actually so many numbers between 1.2 and 1.3, we could go on forever. But at this stage, we're only working with tenths and hundredths. So the only numbers that we would worry about between 1.2 and 1.3 would be 1.21, 1.22, 1.23, and all the way down to 1.29. So this was covered in one of the practice pages that I sent you on Woot Math. So for those of you who did practice that, you might have tried a few interactive examples of this kind of thing. But for those of you who haven't, it's important that we can say that between 1.2 and 1.3, there are a variety of numbers that are between those numbers. So that's kind of it for the introduction of this lesson. But what I really want to talk to you about today is how we can add, subtract, multiply, and divide these things. Now, this is going to be just an introduction to this, and we'll continue on a lot with this when we work with measurement, because it's quite important then. But it's so important that you guys take notes now. So please pause this video, open up your notebooks, get ready to take these notes, and work along with me so that you are actually taking very close attention to what we're doing here and are managing to follow along. So we'll start off with addition. So if you make your heading for this bit, addition, and we start off with 0.1 plus 0.1. Okay, I have 1/10 plus 1/10. How many tenths is that going to give me? 1/10 plus 1/10 is 2/10. This is going to equal to 0.2. All right, if we did that using the grandpa method, we would have it as 0.1 plus 0.1, and we would make sure our columns are lined up, and we base that on the position of the decimal. All right, you'll make sure that all your decimal points are in line, and I'll show you why in a second. But for now, 1 plus 1 is 2. We keep our decimal in the same position. 0 plus 0 is 0, and we get this as our final answer. This grandpa method, or this this grandpa method works exactly the same as if we were doing it with any other numbers. Now, the reason we line up the decimals is because sometimes we end up with numbers that are quite different. So if I had 21.03 plus 202.12, it's a bit different, isn't it? And if we just went along and we started and we lined them up on this side, or we lined them up on this side, it might get a bit difficult. Even if I just said 202.1, if I lined them up from the right hand side, it wouldn't give me the right answer, because these are hundredths and these are tenths, and they wouldn't line up properly. So if I rewrote this, I would try to make sure that my decimal points are lined up. So I'm going to rewrite this as 202.1. Now, with my decimal points lined up, this is really easy. But there's something missing over here. And if there's something missing, it means there are 0 hundredths in that column. So I could put a 0 here if I wanted to. It's not necessarily. The 0 is just a placeholder. So if I added these now, it would be very easy, because my decimals are lined up. 3 plus 0 is 3. 0 plus 1 is 1. I keep my decimal in the same spot. 2 plus 2 is 3. 2 plus 0 is 2. And 2 plus another 0 is 2. So 21 and 300ths plus 202 and 1/10 is equal to 223.13. And that is my final answer. Okay, and the same thing applies for when we carry over across the 9. If we end up having 11 tenths, I would put 1 in my tenths column, and the other 10 tenths would become a 1. Just the same as we did when we added tens and hundreds and thousands and millions and whatever. It is exactly the same when we add decimals. And subtracting decimals works exactly the same. If I had 1.97 and I wanted to subtract 0.85, you see that I've lined up my decimal points. Okay, and now this is going to work exactly the same as if I was subtracting any numbers. I have 700ths minus 500ths gives me 200ths. 9 tenths minus 8 tenths is 1/10. I keep my decimal, and then 1 minus 0 is 1. And I end up with 1.12, or 1/10, and 200ths. Okay? And if we tried this now on an example where we would have to borrow, say for example, if I had 12.12 minus 7.16. All right? I would say, well, I need to take 600ths away from 200ths, but I can't do it. There aren't enough hundredths. So I take away these 10/10, or this 1/10, all right? And I get left with 0/10ths, and that 1/10 turns into 12 hundredths. I've now got 12 hundredths minus 6 hundredths. I can definitely do that. 12 minus 6 is 6. I've now got 0/10ths and 1/10 that I need to take away with it. I can't take away 1/10 from 0/10ths. So I go to my wholes. I take away 1 whole. I get left with 1 whole. And this 1 whole turns into 10 tenths. Can I take 1/10 away from 10 tenths? Of course I can. So I get left with 9 tenths. I keep my decimal in the same spot. Can I take away 7 ones away from 1 1? No, I can't. I take away my 10. I get left with 0/10s. I now have 11 ones. 11 minus 7 is equal to 4. And that is my final answer. 12.12 minus 7.16 is 4.96. Now, I know it might seem like I'm going through this quite quickly, but at the end of the day, these are all identical examples to what we were doing earlier this year. The only difference is the decimal point. Any one of you could have told me what 1212 minus 716 is, and it would give you 496. And the only difference is that we had a decimal point in there at some stage to show us what the place value actually was. So I'm very confident that you guys will be able to do this without much nudging. All right, so that was subtraction. All right, and I forgot to change the heading to subtraction, but you guys can put that in. I hope you guys found this not too difficult and actually very similar to what we've done in the past. I hope that you guys work really hard on the practice questions that I set for you. And please, as always, if you have any problems, let me know. and I will do my best to sort them out as quickly as possible. Also, if you have any questions that you want me to answer in our meet later, please send them to me in an email before the meet so that I can address them, or have them written down so that you can ask me during the meet. Thank you so much for listening, guys. Good luck, and I will see you soon. Bye.